So hello everyone and welcome to today's video. In today's video we will solve the math performance task on exponential functions and polynomial functions. So today we have this document. It asks us to create a PowerPoint presentation and we will use the graphing calculator Desmos. So we have 5 questions. We will go through them, and as you can see, here's my PowerPoint. It's ready. I've prepared a slide for each question. So I've prepared 6 slides. Now this is my graphing calculator. It's Desmos. You go to desmos.com/calculator. So now let's begin with our first question. So let's take a look. It says graph and analyze this function f of x equals 3x to the power 4 minus 6x squared. Describe the domain. So that's 1. The range of the function, the intercepts, x and y intercepts, and end behavior of the function. We will describe the continuity of the function, okay, and we will describe or analyze the increasing and decreasing intervals through the graph. Okay, great. So now we know what we want to do, or what we're going to look for. So we have 1, 2, 3, 4, 5, and 6. I have 6 points we must look for in this function. So now we will take our function and go to our graphing calculator because it says graph. This is the most important thing. So the graph is the first and most important step because we will analyze the graph to get our 6 factors or 6 things we're looking for. So f of x is equal to 3x. Take a look at the function 3x. We will type, okay, I'm not typing, 3x to the power 4 okay, that's to the power 6. We can use the keypad. Minus 6x squared. Great, now we have our function graphed, as you can see. So as you can see, our function intersects the x-axis at some points and intersects the y-axis as well. There are some extremas. We have a minimum here at 1 and minus 1, and we have a y-intercept here. So great. Now that we've graphed our function, let's take a screenshot of it and add it to our presentation. Okay, we will use the snipping tool for that. So we will copy and paste. As you see here, I have formatted everything so that we can add the answer straight away. You can also stop the video here and format your slides so it's just easier to follow along with me. Here I meant to write continuity, but I accidentally left the answer. That was not the plan. Anyways, so okay, great. Now we have our graph and we have our formatted slide. Now we must fill up all these blanks. So looking at the graph, we want to figure out the domain. So my equation doesn't have any square root or fractions, and as we can see, the graph is continuous along the x-axis. That means my domain is all real numbers, or from minus infinity to positive infinity. So that's my interval for domain. So I click on symbols, equation, and I choose the infinity equation to write the interval. Now we'll look at the range. As you can see, it is not continuous for any y value below -3. So the graph starts from -3 and to positive infinity along the y-axis. So my interval is -3 to infinity. Let me copy that. Great. Amazing. So I've done 2 so far. Let's move to the intercepts. First, let's see. Where does my graph cross the y-axis? Exactly at point 0, 0. So my x-intercept, or the point at which the graph intersects the y-axis, is point 0, 0. Amazing. Okay, now x-intercepts. As you can see here, the graph intersects the x-axis 3 times at 3 points. So what we want to do here is we will copy these points to our slide. As you noticed, any graph can have a maximum of 1 y-intercept, but it can have multiple x-intercepts. So let me copy that down. Minus 1.4104, 14, and 0, 0, and we have 1.414 and 0. Okay, great. Now we will move to the end behavior. As you can see, we have our y and x axis. So this is the x-axis and the y-axis. So let's look at our x-axis. As x tends to minus infinity, we can see here along the graph x is decreasing while y is increasing. So as x values are decreasing, our y value is increasing. So here, as x tends to minus infinity, f of x will tend to infinity. Yeah, so let's move to the next. As x tends to infinity, so as my x increases in the positive direction, also my y increases in the positive direction. So my limit, as x tends to infinity, my f of x tends to infinity. Now for continuity, as you can see, my graph is continuous. It doesn't have any holes in it, and my equation doesn't include any square roots or fractions. So my graph is continuous for all real numbers. Great. Now, okay, this is a mistake. Okay, so now for the intervals of increasing and decreasing. As you can see, this graph goes up and down and up and down, and we must figure out the intervals. For this, I'm taking a better screenshot to provide in my presentation. So, okay, I'll do this again. 1 second. Okay, so now I'll take the screenshot after representing or highlighting all the important points where there's an extrema or there's a relative maximum, or where the graph intersects with the x-axis or the y-axis. So this is a better screenshot. So as we can see here, from negative infinity to -1, my graph is decreasing. So look at the x values. My graph is decreasing from minus infinity to x equals -1. And by the way, at x equals -1, we have a minimum, which is called an extrema because it's the minimum value. Again, we look at the graph from -1 to 0, it's increasing, and then look again from 0 to 1, it's decreasing. So 0 to 1, it's decreasing. This is my third interval, and my last interval from 1 to infinity, my graph is increase. Great, so we're done with question number 1. That was a pretty long question, by the way. Okay, moving to our question number 2. So question number 2 is asking us to find all the possible zeros for this function. So first we have the function in front of us. The first thing we notice it is this function is to the third degree. It's a cubic function, so it will have 3 zeros at most. This is the rule. Look at the degree. For example, the degree here is 3, so it will have a maximum of 3 zeros. So it will have 3 zeros at most. Let's graph it. As you can see, I graphed it. Let's see where does the graph intersect the x-axis, which means how many zeros do we have. So yep, we have 3 zeros at max. The graph intersects the x-axis at 3 points. So our explanation is now provided with a graph, and that looks perfect and smooth. Okay, let me edit this or format it a little bit. This looks cute. Okay, remove this, make it bigger. Amazing. Moving to question number 3. So question number 3 is asking us to describe the end behavior of the polynomial function g of x 4x to the power 5 minus 8x to the power 3 plus 20. So let's graph this function first. So the very first thing we should do here is to graph the function to obtain the limits. So we just used the limits, like, I don't know, 10 minutes ago, or sorry, 3 minutes ago in our first question, so it should be easy now. As you can see here, I graphed my function, and so let's suppose we have an x-axis here and a y-axis here, which is there. So x and y. So this is the infinity of the y-axis, and this is the minus infinity of the y-axis. Here's the minus infinity of the x-axis and the infinity of the x-axis. Let's now observe and analyze our graph. So we see that as the x value decreases, the y value decreases. Therefore, we understand that as my x tends to minus infinity, we will use these again. These will come in handy, so just copy them. Okay, as my x tends to minus infinity, my f of x tends to minus infinity as well. Great, now let's move to the second one. What happens to my graph as my x goes to infinity? Yep, you guessed it right. My f of x increases. So now I took a screenshot of my graph, and I need to crop it to make it obvious and clear. And we have to increase the size here so the teacher can see it. Great, we finished question number 3. Okay, let's copy the function so we know what we're talking about here. Great, now moving to question number 4. For functions for the function y equals x squared. So first of all, it's better to graph y equals x squared. So yep, this is our function, our original function. Okay, and now we will modify it. We will add transformations. So this is the transformation provided, and we will describe this transformation after we graph it. So always when you have transformation related question, always use the graphing calculator, graph and analyze the graph to get to the most accurate answer. So we have y equals x minus 2 raised to the second power and plus 3. Great. So we can see the transformation in purple. So this is our we can call it our second graph. It's not our original, our new graph after the transformation. So let's figure out what happened here. First, okay, we reflected the x squared across the x-axis. So first we reflected it, it is reflected, and then we moved it 2 units to the right. My h is 2, so we moved it 2 units to the right, and finally we moved it 3 units up. My k is 3. So now let's take a screenshot to provide in our PowerPoint. Great. Now let's list the transformations that happened here. First, reflection through x-axis, through x. The second thing that happened was a translation 2 units to the right. It means my h is 2. And also we had a translation of 2 units up. I think it's 3 units up, yeah? So 3 units up. Right. That means my k is equal to 3. Perfect. So this is my answer. Let me increase the size. And I will also add my question here for reference. Copy and paste. Okay, great. This is my question. This is my answer, all clean and tidy. Great. Moving to the 5th and last question. For the function, okay, we've got another original function and another transformation. So we have function x cubed. X cubed. Okay, let me delete that. What is the transformation here? Okay, it's minus x cubed, so y. Okay, as you can see, this is our original graph in green, x cubed. So the transformation here is y equals negative x cubed. So the first thing we notice here is the graph reflected through y, and yeah, minus 4. As you can see, after we reflected it through y, my graph had a translation of 4 units down. So if we remove the 4, we see the first transformation, a reflection through y-axis, and we have 4 units down, translation of 4 units down. I hope that's clear. Now let me take a screenshot of that to provide in my PowerPoint. It would be so helpful. So anyone looking at the PowerPoint can understand what I'm talking about and how did I. So first of all, reflection through y-axis. And then we have a translation of 4 units down, meaning my k is -4. Okay, now I have to add my question for reference, so we know what we're answering. Okay. Only question number 5, so copy and paste. Great, now we've finished our 5 questions. This is my answer highlighted. Okay, let's add a new slide, a thank you slide, because the teacher had spent a couple of minutes reviewing your work. So thank you. Okay, I'll come back in a second. Okay, so thank you for watching. I hope you enjoyed. I hope it was nice and easy. So leave a like if you like this video. Subscribe to my channel. See you in the next video.